Hello. I'm Irene Brusini from the Royal Institute of Technology in Stockholm, and today I'm going to talk about a preliminary study on the influence of the tractography method that we are using on our estimation of curvature of the neural tracts. So, first of all, let's briefly see what tractography is. Probably many of you have already seen these nice, colorful 3D models that are the result of tractography. And they are created using diffusion MRI data, and they represent a set of neural fiber bundles that we have in the white matter and in the brain, in our specific case. So in literature, there are many, many algorithms that can reconstruct these kind of models, but they can be mainly divided into two big classes, deterministic and probabilistic algorithm. And these two methods use different approaches to reconstruct the direction of our tracts. So sometimes we can get quite different results using the two methods. But anyway, no matter which method we use, what we get in the end is a set of 3D curves that you can see here, and every curve is a tract. So as any 3D curve, we can extract many geometrical information from them. And one of this information is curvature, which, as you can see here, was used in several applications, for example, to study autism, or also to assess its outcome in brain injuries, or to study the diffusion properties of the white matter. But anyway, as we saw before, there are many different methods to get these tracts. So what we've been wondering is, does the choice of the method that we use going to influence somehow the curvature estimation that we do and that we use afterwards in our studies? So to investigate this, I took two subjects from the Human Connectome project, so very high quality diffusion data, and I applied on them two different tractography algorithms, one deterministic and one probabilistic. And then for each of these two algorithms, I tested different step sizes between 0.1 and 0.7 millimeters. And the step size is basically the distance between two subsequent points in the tract that we're gonna reconstruct. So in the end, we get 8 different tractography data sets with completely different settings. And for every tract of every data set, we can compute the curvature in each of its points. For example, there for point pi. And if we average the curvature values of a tract in a voxel, we get voxel-wise curvature estimations. So we have very local estimation of curvature of every tract of every data set. So I took all my curvature estimations, and here, for example, for subject 1, I represented these distributions in all our experimental settings. And subject 2, anyway, showed basically the same distribution. And as you can see here, if we change the experimental settings, we get quite different curvature values. And not only there is a difference between deterministic and probabilistic approach, but also between different step sizes, even if they are the difference is quite small. For example, in probabilistic case, the difference in the distribution is quite big. And here, I represented basically the mean values of the curvatures of the distributions that you saw previously. So also we can see opposite trends. If we increase the step size, we see that in the deterministic case, we have also a slight increase in the average curvature of the tract, while in the probabilistic case, there is a decrease, almost a linear decrease, together with an increase in step size. So this could suggest that maybe if we study curvature at smaller scales, we have very irregular tracking with probabilistic tractography, smoother tracking with deterministic one. So again, different results. So the main observation that we can draw from these results is that local curvature estimations are actually very sensitive to the choice of the method that we use. So, well, first of all, we have to use always the same method if we want to get comparable results. But also, I think it's very important to further investigate if this local information are actually reliable, because we saw that they are highly sensitive also to very small changes of our settings. And this is all. This is the rest of the group who worked on this, and we are all part of the Medical Image Processing and Visualization Unit of KTH in Sweden. We work on tractography, neuroimaging, and also other topics in medical image processing. And I thank you for your attention, and I hope to meet you tomorrow at the poster session.